We are recording now, as the little robot voice just told me. So, before we get started, I'd like to thank the founding partner from SJSU. I've worked with them for a while. I worked with them before I knew that they were actually founding and helping with this, so that was a pure coincidence, but they are delightful. So my name is Amanda Sweet, and I'm with the Nebraska Library Commission. I'm the Technology Innovation Librarian, and I'm going to be talking about introducing AI with practicality and purpose. And this actually came about because I was helping a lot of different libraries introduce AI to their communities, but it just turned into we did a fun activity, but it didn't really go much beyond that. And we heard like an endless litany of ways that AI is being used, but none of those applications actually encourage people to explore and dig deeper into artificial intelligence. Like it's fascinating and amusing that AI is being used to, in our smartphone cameras, to be able to focus the camera onto a person's face. And it's awesome to know that like hundreds and thousands of images of faces was used to train the model that's baked into our phone systems right now. But simply knowing that information doesn't really inspire people necessarily to dig deeper and learn more about their role in AI. So I started to rethink this and say, if we had a whole bunch of, if we hosted all these different events and activities and the library inspired at least 20 people in your community to be an AI engineer or a business analyst or go into some role related to AI, where would they actually go? In your local area, in the state, in the region, in the nation, around the world, why should people actually care about and pursue AI? So instead of how we can introduce AI, let's start with the problem AI is solving and why people should care. And that's what we're going to talk about in this session to be able to help people use AI with purpose. So this is kind of like a general framework for how this works in library land. Right now, libraries are already working with the demographics below. And most of the activities that I help libraries set up are for K through 12 high school and to an extent, adults. But now this is branching out more because a lot of our communities were being hit with layoffs. We need to drive innovation. We need to create more new jobs. And the library is trying to find new ways to add value to our community. And in a lot of ways, this is going to revolve around introducing technology. So the library can now introduce new ways to support entrepreneurs and innovators and help people figure out how to leverage this new technology that we're introducing in better ways. Because our world is changing and we need to help prepare our communities for that to happen. And that's how practicality and purpose happens. So, in order to do this, we need to start reframing how we look at technology, how we look at the role of the library, and how we look at the ways in which we introduce this to go beyond just a simple STEM and STEAM activity that gets hosted in the library and to expand into community conversations, innovation labs, bringing in guest speakers, partnering with businesses, and trying to find new mechanisms and models to be able to start small and then expand out into doing awesome, amazing things with AI and other emerging technologies. And you're going to hear what AI is ad nauseum if you haven't already. So I'm going to gloss over that and just say that AI is a tool that's used to help the computer act like a human. It helps the computer it helps the computer replicate human senses to make decisions about the world, and it integrates with different hardware to be able to accomplish that. So, for example, the webcam that I'm looking at right now and the webcam that is the reason you can see me is also a sensor that the computer uses to interact and understand the world. So, when you have a robot that's AI enabled that's roving down a street, that little sensor is the robot's eyes. And there's a little AI model that's baked inside of it that says this robot was trained by about 1,000 different images of faces. So now when the camera that's mounted on the back of a robot is roving down the street, it can now recognize a human face without being told directly that that is a human face. And this is also the same way that your smartphone camera works. So if you think about AI, you're thinking about a computer being able to do human tasks and have human intelligence. And every single human sense that we have, there's now a hardware component that's trying to replicate that. Your eyes are now a webcam or a camera. Your fingers may be a little pressure sensor that's on the edge of a robot. So while your fingertips can press against a hardwood floor and know that that you have just hit the floor, the hardware equivalent to that is a robot arm that has a pressure sensor. So when that sensor registers that it hits the ground, there's a sensor reader in there that says something changed. There's a texture change, we hit ground. And that's how the computer knows that now. And so just start thinking about how the human sense works and how this translates over into computer land. And we'll dig deeper into that, and I'll give you some resources to be able to better understand that and explore what that looks like. But in order for libraries to be able to introduce this technology to their communities, we have to know what that technology is and why it's relevant to the local area. So let me just mosey on here. The best way that I found to introduce um, how innovation works and how libraries can help people with technology and innovation process is by walking through the process of how innovation actually works at large scale. So on the left-hand side here, this is called the grain weevil robot. The grain weevil robot actually uses little augers to be able to go across the top of a grain silo bin. Before, you would have a human that would actually have to crawl inside of a grain silo bin and manually break up all these little granules. And sometimes, like, horrific accidents would happen where this farmer would get sucked down and sink down into this grain bin. And some have lost their lives, some have been hurt horribly. So this is actually a robot that was made here in Nebraska, and this was made by a university student who already had exposure to robotics and was fascinated by just learning everything he could about robots. And he went back home one day and he visited a family friend who happens to be a farmer. That farmer said, I would love you forever if you could build me a robot that would make it so that me and my friends never have to go into a grain silo bin. And this kid just said, challenge accepted. And over the next few years, he went through and every time he would have a break from college, he would come home and he would start designing this robot. And the robots that we see now in library land, usually they're rolling on wheels. Maybe they might be on little tracks, but this uses the augers to be able to propel itself forward. And then it has like a little light so that you can, not so that the robot can see, but so that the human that's connected over virtually can see where the robot is going. And now instead of a human going through there, it's the robot. And in order for that to happen, this person had to gain exposure to the robotic technology. They needed a path to be able to progress those skills beyond just a simple introduction. So this person actually gained exposure to technology in I believe it was their high school, if I remember correctly. But in library land, if we want people to come into our makerspace or come into our library, we need to be able to give them exposure to this robotics technology, but then give them the path to be able to progress their skills forward, connect them over. And what this means would be connecting people over to robotics communities online where people can actually interact on forums with real other humans, connecting them over to the local business community where people are actually working with beginners and working with people that they're trying to attract talent into the robotic sphere. And then this also means libraries being able to refer people over to education and training programs that are local, state, online, just anywhere, so that people aren't just circling around in chaos trying to figure out where to go. And I have a bunch of those referral mechanisms in place that I'll link over to later in this presentation so that you're not circling around trying to find where to go. And then the third thing is, in order for innovation to happen, whether it's in someone's existing job, whether it's someone starting a new business, or whether it's someone who's just solving a community problem that's out there in the world, you need exposure to the tech, so you need to know what the tech is going on. You need to be able to build those skills or connect with other people who have those skills. Then you need exposure to a problem that can be solved using that technology. And if you don't have those three things, you don't have innovation. So another one of the things that the library can do is start curating problems and start bringing in guest speakers to say, this is what's happening in the world of climate change. This is what our farmers are facing right now. This is what we actually need. And even if it's a problem that doesn't have a solution yet, that is half the battle. And it's getting these people that know the tech together with the people who have the problem to be able to start forming teams and forming a solution. And that is the trifecta of innovation at any age. Kids can do it, teenagers can do it, adults can do it, and anyone can do it. And then in this case, he actually turned it into a business. Like he figured out how to navigate all the regulations and make sure that it's safe for human use, and he did all this different stuff. So is one path. Some people might turn it into a nonprofit, others might just turn it into a one single localized solution that doesn't really need to scale and grow out into anything beyond just that local solution. So, but this means connecting over to support organizations that can help you build a business, support organizations that can help establish a nonprofit and keep it sustainable, and support organizations that can help um, leverage technology to solve problems. A lot of times that means connecting over to vendors like IBM or something that already has a pre-existing technology to be able to customize the tech to solve the local problem. And then the last part of it is like having that community support network because doing all this stuff is hard. It can be disillusioning. It's just freaking hard. So it's having the people that you can go to say, I had a really hard day and I need a little pick me up. And that is just how people get through. So this is the path that libraries are trying to help people get through. This is if you look around your community, you've probably seen this in action. But before, this was just chaos. Now we're putting in library land, we can help people put rhyme to reason so that we can tell people, let's get some tech and some problems together in the same room and see what shakes out. And it's as simple as that. So, in most cases, the vast majority of people are not actually going to start a new business. We need people that can do that, but most people are actually going to be just joining existing industries or joining jobs or driving innovation within existing organizations. So the first thing to introduce practicality into our library activities is to be able to customize and cater our STEM and STEAM activities for all ages to localized industries. So the way that I do that is to say, just pick any industry. Here in Nebraska, our major industries are manufacturing, agriculture, fintech, I have a whole little infographic that has all of our top industries, and they shift and slide slightly by region, but we use a tool called AnyWorks to be able to search the localized industries and find out what's going on when, where, and why. And there's also another tech hub that's showing what's going on, who, what, when, where, and why. So tracking those local trends or connecting over with people who do track those local trends is kind of like the start there. And then the next stage over is to figure out now that you have an industry or you have a local business, it's choosing an activity that will reflect some subset of that industry. So for example, if you have a if you have a really big budget, you can use something like the DoBot to introduce manufacturing. And the DoBot is this really cool robotic arm, but it has like this amazing curriculum that can be used for any age level or age range, and it can scale up from like around fifth to sixth grade up on into high school and adult age range. And it's a really great tool to introduce actual industry techniques. If you don't have a whole boatload of money, you can also introduce the robot arm that might be customized through, I believe it's UB Tech that actually makes it. And basically, you can search robot arm kit, and there's probably quite a few of them. And you can use that to be able to introduce different concepts that are in the most common one that I use is actually the smart warehouse technology. So it's being able to introduce human-computer interaction and how robotics work inside of that warehouse environment. So human-computer interaction is you have the robot arm that might be unscrewing a part, and then the robot swings over and then it drops that screw into a bin, or it'll pick up a screw from a bin and then it will connect over a car part. The human computer interaction part of it happens because that robot is often working alongside an actual human person. So that robot needs to be able to know whether that person is standing next to the robot arm or not, so that when it swings over, it doesn't smack into an actual person. And that's when it starts using a sensor to be able to know when an obstacle is in front of it and to know whether it should stop or keep going. And then the human actually needs to be able to be cognizant of the world around him so that he or she knows that this robot arm is there and can navigate around it or interact with it. And the robot may be programmed so that it knows that if a human swats the robot arm away, it knows to stop. And it's actually AI that it can be used to train the robot to stop if it's swatted away. The way that it works is that you have the robot arm and it has like a little sensor inside of it that says that can recognize when it's been tipped to a certain degree. And it says if the robot arm is bumped over 30 degrees, it knows to stop. And you don't have to manually program it because you can just give it about 50, 100 examples of a person tapping it, tap it, tap it, tap it. It gathers that information, gets the example, and then it says, then you tell it, from these examples you were just given, you know that tapping 30 degrees means stop. Tapping 20 degrees means stop. Tapping 25 degrees means stop. And it figures out the range and starts to use this data to detect patterns so that the next time the robot arm is moved, whether you tell it to stop or not, it knows to stop. And that's called a training set to be able to give the robot arm examples so that you have enough examples and a good enough training set to know without being told that anything within this degree range means stop. And that is just a tiny way that AI is being baked into the technology around us for practical purposes. And since a lot of librarians are not going to know the specific weird nitty-gritty ways that technology works in different concepts, I made a database. And I'm going to go into my Google Sheets because there's a few other ones in here that might be helpful. So I'm going to jump on down to the Technology Innovation Database. And so these examples are out of Nebraska just because that is where I am. And in here, this is the organization name over here. If you follow it across, you can find which technology is actually being used by that organization. You'll find the mission statement and what this organization is actually doing. And then you can jump over to find a video to demonstrate how this technology actually works, an article describing either how the technology was made or how it works. And just watching that video and being able to read that article gives you incredible context on how this technology actually functions. And the way that this is used in activities, whether it's for K through 12 or adult, is to be able to do an activity that is this drone amplified is actually it's a drone that does precision burn. So you can set, instead of having a firefighter go out into the danger zone and like basically start a fire in the middle of a field to be able to burn out like the dead crops and like the undergrowth so that a wildfire doesn't start or so that like basically you're burning it first so that nature can't do it for you. And then instead of having the human do that, a drone actually flies overhead and drops a little ignition bomb. They call it a dragon's egg. And it drops this little bomb in a precision spot to be able to start that precision burn. And this is a good thing to pair with something like a co-drone activity. I used to pair it with a DJI Tello drone, but then they stopped making DJI Tello, and they haven't found like a super great replacement for a drone like EDO drones anymore. But the closest that they have right now is co-drone. It's a tiny, adorable little robot. It's cute, but it can blow away in a stiff wind. So I recommend actually doing that one inside. But so basically you do that, but then you play that video and then ask people to start reading that article and start launching discussion questions and start saying, how would you start using this to solve other problems? How else how would you change this technology to make it better? How would you, just like a whole bunch of different things that you could do, and ask people to start searching for how drones are solving other problems and start imagining different ways that drones can practically be used instead of just as a cool thing swinging through an obstacle course in the library, which is fun, but doesn't get people to the next level. I actually really do like my book obstacle course in the library though, so don't hate on obstacle courses too much. And the other database that I put together, and I'm going to go down into here. So, and don't worry, these are all linked later in the slide deck. I'm just bringing them up now. So if you're going to ask me if I can link over to this, sure, it's in there. So on this left-hand side here, I chose a bunch of the kits that I actually circulate here in the Library Commission. So this is the Dash and Dot robot, and this is an activity that just detects light waves. So it detects like there's a little light sensor that shoots out from the robot, and you can tell when that light has been blocked off. And then you jump on over here to say, let's look at the bigger picture here. How is this simplified technology actually being used in the wider world? And you can say that So right now we have brain-computer interaction, and there's now technology that can get, there's like a little sensor that can be put onto the top of your head so that it can either it can detect tumors without being able to cut open anything. It can detect the amount of fluid in your brain. So it's being used for medical purposes and it's being used for a lot of different reasons. This open water actually uses it for detecting tumors in the brain. And it's actually like a little light that gets shown down into the brain, and then that tumor is the obstacle that blocks it. So it's the same exact concept that you just learned using dash and dot, that super simple activity, but then it's put into greater context. So if you or your library don't have like a whole ton of time to be able to scout around and find all these different practical applications, you can scout through this database and use this to extend over the simple concept into the bigger picture. And so I've got like a little collection of these and I'm growing more of them, but there's also the whole like so much time in a day, so I'm trying to grab more people to help like add more of these. So if you're interested in helping to build out more of this stuff, you let me know. And I'm also trying to add more examples of different tech activities and stuff, because there's a lot of tech in the world. So you can, this is like a good little launching pad to translate into, to like build the understanding of the technology and then translating it over into here. So I'm going to jump back on over into here. So this is like the customizing the tech activities. If you don't have a ton of time, just grab it from the database. And this is kind of like a little cheat sheet about how to match the tech to the industries. And on this left-hand side here is an example of some of the emerging technology that's out in the world. I just read like a whole bunch of the World Economic Forum reports and all these different industry reports, found the tech that's shaping the way we all live and work, and then grabbed a common industry that's in pretty much all of our communities, took it into this little industry column, and then found this is the bigger example of how the robot is being used in industry. If you've ever been to a robot that has that little rolling robot that delivers the food to your table, this one is named Servy, and it uses a pressure sensor to know when the plate is removed. And if you've ever done the microbit pressure sensor pressure switch alarm, that's a super simple introduction from pressure sensors into robots. So it's just building out this little simple chart. And I do workshops and stuff to help people do this, so that's how that happened. But let me jump over into the resources. I only have a minute left and I want to get you out of here on time. So click over through these resources to find some of the databases that I clicked over to, a gadget guide if you're looking for which technology to buy to introduce like Industry 4.0 tech, and then there's some stuff in here. If you're in Nebraska or you want to find out how a tech kit circulation system works, you can click this link and you can also flip through the rest of the slides to find my contact info if you want to be able to reach out to me. And we got a minute. You can ask questions if you can type quick, but I will link over to the slides because this is just Google Slides. Share, copy, and slides accomplished. So it is 3:30. I had planned to give you at least a couple minutes to, oh, access denied. Let me try take two. Share. You are right.
You know,
Anyone
Amanda,
with
the
the
best
link.
way to share is to put the slides in your original forum discussion as an uploaded document, and people can just go to the Library 2.0 site and find it there. This never really works, this kind of sharing.
Fair. And I did update the access on here so that anyone can view it before it was restricted. But I will also put it out through the portal that you just talked about. So it is 3:30 on the dot, and you are welcome to jump off into your next session, or if they'll let me, I'll answer questions. I'm glad y'all liked it.